There's a city on the coast of South America where for half the year the sun can disappear for weeks at a time. Lima sits in the tropics. It's closer to the equator than Hawaii is by rights. It should be hot and bright. It isn't. From roughly May to November, a flat gray lid of clouds slides over the city and simply stays there week after week. Locals have a name for it. They call it the donkey's belly. This winter, that lid lifted. In June, parts of Lima were 5 to 6 degrees Celsius warmer than normal, with afternoon temperatures approaching 30 degrees Celsius. Centuries ago, fishermen on this same coastline noticed something similar happening every few years. The sea suddenly became warmer, fish disappeared, and their families struggled to survive. They gave this strange event a name, El Niño, meaning the little boy. What they didn't know was that they had discovered the visible edge of the largest natural disruption Earth's weather system can produce. Today, that same phenomenon is building across the Pacific faster than almost anyone expected. It has already emptied Peru's fishing nets, it has already disrupted India's monsoon, and now it's heading toward a planet that's already hotter than at any point in recorded history. So how does a patch of unusually warm water in an ocean most people will never see end up deciding what happens in cities thousands of miles away? Why is this El Niño different from the previous major events? And most importantly, what could it mean for our entire planet in 2026? To understand that, picture the Pacific Ocean as an enormous bathtub. Under normal conditions, powerful trade winds blow from east to west across the tropical Pacific. These winds push warm surface water toward Indonesia and Australia while allowing cold, nutrient-rich water from the deep ocean to rise along the coast of South America. This creates the Pacific's normal balance: warm water in the west, cooler water in the east. But El Niño begins the moment those trade winds weaken. Instead of remaining piled up near Asia, the warm water starts sliding back east across the Pacific until it spreads over the normally cold waters off South America. Once that happens, the cold water upwelling slows dramatically. Without that upwelling, nutrients disappear. Without nutrients, fish populations collapse or migrate into deeper, colder water. That's why Peru's fishing industry is always among the first places to feel El Niño. But this isn't just a story about fishing, because what truly changes the planet isn't the water itself, it's what happens above it. Warm water evaporates much faster than cold water. That moisture rises into the atmosphere, producing massive thunderstorm systems. Wherever the warmest ocean water exists, enormous columns of rising air develop above it, transferring huge amounts of heat from the ocean into the atmosphere. These rising air columns influence the jet streams, the powerful rivers of wind high above Earth that guide storms across entire continents. Move the warm water, you move the thunderstorms, you move the jet streams. And once the jet streams shift, weather patterns begin changing across thousands of miles, affecting Asia, Africa, North America, South America, and even parts of Europe. The question was never whether this shift would happen. The real question was how quickly it would happen and how strong it would become. Scientists constantly monitor one specific region in the Central Pacific because it's one of the best indicators of El Niño's strength. Right now, that region is running about 1.2 degrees Celsius above average, and temperatures continue rising. That number may sound small, but warming such an enormous area of ocean by even 1 degree requires an almost unimaginable amount of stored energy. The ocean absorbs heat slowly, which means when ocean temperatures climb this much, they're storing extraordinary amounts of energy waiting to influence the atmosphere. But temperatures alone weren't what convinced scientists that this event was accelerating. The real turning point came when they observed thunderstorms beginning to form over the central and eastern Pacific while weakening over Indonesia. That meant the atmosphere itself had responded. The massive column of rising air had physically shifted east. This wasn't a computer prediction, it was a direct observation. The ocean had changed, now the sky had changed too. That's why forecasts became much more serious. Scientists now expect this event to strengthen significantly between October and December, potentially becoming one of the strongest El Niño events recorded since reliable observations began in 1950. Events of this size are exceptionally rare. Only 5 have reached similar strength in the modern record, with historical evidence suggesting 2 more likely occurred during the late 1800s. The difference today is that unlike people living in those earlier periods, we can actually watch this process unfold months before its biggest impacts arrive. The first country already experiencing those impacts is Peru. Peru's anchovy fishery is the largest single-species fishery on Earth. Most people have never heard of it, yet millions unknowingly depend on it. These anchovies are processed into fish meal used to feed farmed salmon, chickens, pigs, and other livestock across dozens of countries. When cold water stops rising from the deep ocean, the anchovies lose their food supply. Many die. Others escape into much deeper water where temperatures remain cooler. Fishing crews have recently reported finding schools of anchovies more than 100 meters below the surface, far deeper than normal. The effects became visible almost immediately. Authorities reduced Peru's seasonal fishing quota to 1.9 million tons, the smallest allowance in a decade and more than 1/3 lower than the previous year. Even that reduced target quickly became impossible. By early June, fishermen had landed only about a quarter of the allowed catch. Even more worrying, over half of the fish being caught were juveniles that hadn't reproduced yet. Catching immature fish doesn't just reduce this year's harvest, it threatens next year's population as well. Recognizing the danger, Peru officially shut down the fishing season on June 11th, the same day El Niño was formally declared, but Peru is only the beginning. The next link in the chain affects nearly 1/5 of humanity: India. India's relationship with El Niño has always been uneasy. When the massive column of rising air shifts eastward over the Pacific, the atmospheric circulation that normally drags moisture toward the Indian subcontinent begins to weaken. Meteorologists have watched this pattern for decades, which is why India's weather department lowered its seasonal monsoon forecast before the rains had even begun. Unfortunately, June proved even worse than expected. By the end of the month, India had received nearly 41% less rainfall than normal. For a country where agriculture, drinking water, and food production depend heavily on the monsoon, that wasn't simply a dry month, it was the beginning of a crisis. Then everything changed almost overnight. During the first week of July, multiple storm systems swept across the country. The monsoon suddenly returned with tremendous force. That 41% rainfall deficit rapidly shrank to around 15% in just 8 days. But the return of the rain didn't solve the problem. Instead, it created a different disaster: floods, landslides, road collapses, entire regions placed under red alerts. This is what makes El Niño so dangerous for India. It doesn't always eliminate rainfall. Instead, it makes rainfall unpredictable. Long dry periods are followed by intense cloudbursts, then another pause, then another violent burst. For farmers, total seasonal rainfall means very little. Rain arriving weeks late cannot save crops already damaged by drought. Likewise, rainfall arriving all at once often destroys fields instead of nourishing them. The timing matters just as much as the amount. There's another reason scientists remain concerned. The Indian Ocean has its own climate pattern called the Indian Ocean Dipole, which can sometimes offset El Niño by pulling additional moisture toward India. In previous years, it has helped rescue weak monsoons. But this year, it has remained largely neutral. No significant assistance, no balancing force, which means El Niño is operating with very little opposition. While India struggled with its shifting monsoon, Europe was experiencing something entirely different. Western Europe recorded its hottest June ever measured. France experienced its hottest day on record. Germany shattered national temperature records. Barcelona climbed above 40 degrees Celsius. Thousands of heat-related deaths were estimated across the continent. Many people immediately connected these events to El Niño. It seemed obvious: a warming Pacific, a scorching Europe. Surely they were linked, but climate researchers reached a different conclusion. After running detailed simulations, they found that El Niño played virtually no role in Europe's record-breaking heat. Instead, Europe was suffering under an enormous heat dome parked over what has become the fastest warming continent on Earth. Compared to the mid-1970s, Europe is already around 2 degrees Celsius warmer on average. So why does this matter? Because it changes how we should think about what's coming. Europe's historic heat wave wasn't the result of El Niño, it was the baseline, the floor. El Niño hasn't delivered its strongest influence there yet. Historically, the largest impacts arrive during autumn, winter, and even the following year, which means Europe may still experience additional pressure from El Niño on top of temperatures that are already exceptionally high. That combination is what worries scientists. Now here's something that surprises many people. A very strong El Niño actually tends to reduce hurricane activity in the Atlantic Ocean. That sounds impossible. But there's a simple explanation. When the Pacific becomes unusually warm, atmospheric circulation changes across the globe. High above the Atlantic, stronger upper-level winds develop. Meteorologists call this wind shear. Hurricanes need calm, organized conditions to strengthen. Wind shear tears those storms apart before they can fully develop. Because of that, forecasters predicted a quieter than normal Atlantic hurricane season. Colorado State University even reduced its seasonal outlook to roughly 11 named storms, significantly below average. But there's an important catch. The Pacific experiences the exact opposite. As El Niño strengthens, wind shear decreases across the eastern Pacific. Storms there encounter much more favorable conditions. That allows tropical systems developing off Mexico and Central America to strengthen more easily. So while one ocean becomes quieter, the other becomes much more active. Whether that's good news or bad news depends entirely on which coastline you live near. Of course, hurricanes are only one piece of a much larger global picture. Because a super El Niño doesn't affect every country in the same way. Some regions receive far too much rain, others receive almost none. Let's begin with North America. The southern United States, stretching from California across Texas and toward Florida, generally becomes wetter during a strong El Niño. An active jet stream carries repeated storm systems across the southern states. For drought-stricken areas, that extra rainfall can be beneficial, but for flood-prone communities, it creates entirely different risks. Farther north, conditions usually reverse. The Pacific Northwest and Northern Rockies often experience warmer and drier winters. Snowpack decreases. That might not sound important, but mountain snow acts as a natural water reservoir, slowly releasing fresh water throughout the summer. Reduced snowfall means rivers run lower later in the year, water shortages become more likely, wildfire seasons grow longer and more intense. The upper Midwest usually experiences a milder winter with temperatures remaining several degrees above normal. Across Canada, western provinces including British Columbia and parts of the prairies often become warmer and drier as well, increasing both drought and wildfire risk. Eastern Africa experiences another very different outcome. Countries including Kenya, Somalia, and Ethiopia frequently receive above-average rainfall during El Niño. More rain might sound beneficial, but recent history shows otherwise. Even the 2023 to 2024 El Niño, far weaker than the one now developing, produced devastating flooding that displaced hundreds of thousands of people. South America faces multiple threats simultaneously. Peru's fisheries have already begun suffering. Farther inland, the Amazon basin faces increasing heat and drought. Large sections of the rainforest are already under enormous environmental pressure. Additional drying dramatically raises the probability of widespread wildfires similar to those seen during recent catastrophic fire seasons. Meanwhile, southern Brazil, Uruguay, and Argentina often experience heavier rainfall, increasing flood risks across low-lying regions. Australia presents one of the clearest El Niño signals anywhere on Earth. The warm Pacific water that shifts eastward is effectively moving away from Australia. That means less evaporation, less moisture, less rainfall. Eastern Australia usually experiences hotter temperatures, shrinking reservoirs, stressed farmland, and significantly higher bushfire danger. Yet all these regional impacts still aren't what makes this event truly extraordinary. The biggest difference isn't El Niño itself, it's the world it's arriving in. Every previous Super El Niño developed on a much cooler planet. This one is unfolding after 11 consecutive years, ranking among the warmest ever recorded. El Niño doesn't create entirely new heat. It releases heat that has been stored beneath the Pacific Ocean for years. Normally, much of that energy remains trapped below the surface. As El Niño develops, enormous quantities of stored heat escape into the atmosphere. Global temperatures rise accordingly. That has happened during every major El Niño event. The difference today is where we begin. The baseline is already the hottest in recorded history. Adding El Niño's natural warming on top of today's already elevated temperatures pushes the climate into territory humanity has never directly observed before. So where does that leave us? This isn't a prophecy. It's one of the rare natural events scientists can watch developing months before its greatest impacts arrive. The Pacific Ocean is following patterns it has repeated for centuries. The difference is that today we can monitor every stage almost in real time. International organizations have already requested emergency funding before the worst droughts begin. India prepared emergency plans for hundreds of districts before the monsoon weakened. Peru halted commercial fishing before the fish population collapsed further. For the first time in human history, we're watching every link in the chain form before the final consequences reach us. The Pacific hasn't changed, it has always behaved this way. What's changed is our ability to see it coming. Before you go, I'd love to hear what you're experiencing where you live. Has your weather felt unusual? Have winters become warmer? Has rainfall changed, or have seasons stopped behaving the way they used to? Leave your observations in the comments, because together, people watching from around the world provide a picture that no single forecast can fully capture. And if you'd like to leave Earth for a moment, our latest episode explores what's happening deep beneath the surface of Mars, where the planet itself refuses to stop shaking. I'll see you in the next one.